Hi. We're all familiar with these crimp terminals, very commonly used for medium to high current applications. In all sorts of flavours, from sort of wire splices to eyelets and spade connectors and so on. And with the right tools they produce a very quick, reliable connection. So of course, with these tools you need a crimp tool. This is not a crimp tool. These things are utterly useless because they don't give you any guarantee of how much crimp pressure is applied. They're just an absolute joke. However, there is one and only one reason that you should own one of these. They've got these really handy screw cutters in there, so if you need to just shorten a screw, you can just screw it in, shears it off, you pull the screw out and it cleans the thread up. Really handy, but this is the only part of this tool that you should ever think of using. No, for proper crimping of these you need something like this. This is a ratcheting crimp tool, fairly commonly available, and the key thing about this is, apart from, as well as having sort of nice sort of heavy duty jaws, it's got the double jaw, so it crimps in two places at once, but it's got this ratchet, so it makes sure that it always closes fully before it allows it to release. So it means you're always guaranteed that it's always crimped to the right distance for that terminal. Yeah, so these are pretty good. They do vary. I mean, this one's actually quite good, but they do vary. Sometimes the handles are really uncomfortable. This one's sort of not too bad, and sometimes they're quite stiff. And certainly for for smaller contacts, they're not too bad. But the red ones you can usually do one handle. You tend to quite often use two hands just to give more of a boost. But once you get up into the big yellow ones, for sort of typically for 4 and 6 mil square cable, it does actually become quite an effort to use these. You generally need two hands to do it, and it's okay for the odd one or two, but if you've got like 20 or 100, then it can actually become quite. You end up with very sore hands. So I've got an upcoming job that's going to involve crimping quite a lot of these, and a while ago I saw quite an interesting gadget that might help. This is the Klauke EK 50ml crimp tool, and it is awesome. It's basically designed to look and feel very much like it's more a power assisted hand tool than just a power tool. So as you move the handle, until the jaws actually close, it's just a completely manual operation. So you can get things lined up nice and easily. You can get your terminal in, and only when it actually just starts gripping, you then press the handle, and it crimps really quickly, really easily. So you can get it all nice and lined up, everything dead right, and then just go. And all the other thing is it holds it while you're holding the handle, so it doesn't like release it automatically, then drop the thing off. So you grab hold of it again, release it, and you've got your cable. And it does, it will do the yellow ones just as easily as the red ones. According to the manual, it's got up to 15 kilonewtons force, so that's about 1.5 tons of clamping pressure. But so even these yellow ones, boom, job done. Really nice, and just the way it's been designed, say it only start going once it's closed, so it's actually quite difficult to sort of get your finger in and sort of crimp your finger or anything. The feel of it's quite nice. It's got a real solid feel. I think it's made in the German. The battery's made in Germany. The tool itself, made in Germany. So it's got a really nice solid feel to it. 10.8 volt lithium battery. It's 1.5 amp hours. They reckon the lifetime of that is 300 crimps, but that's on the big 10 square mil crimps. Probably expect it to last longer on lighter weight ones. A really nicely made. It's not cheap. It's about 400 quid, but if you're crimping a lot of these things, a good 1,000 crimps, it's probably paid for itself, if only just to save your hand from being knackered. It's got this lanyard thing, so this is if you need to put it onto a tool belt, or if you need to use a safety harness, like if you're working up a cherry picker or something, so it doesn't get dropped on people below. It's quite nice. It's not too heavy. It's just got it just really has got the feel of it's one of these but on steroids. It's just absolutely really nice. You don't want to sit here all day just like popping bubble wrap, just crimping. It's just got such a satisfying action to it. It's just fabulous. Just sit here all day just crimping things. couple of minor things I don't like about it. It's got this light, which is great, really handy. The problem is it only comes on when it starts actually crimping. I think what you really want it to do is start, you know, as soon as you just push the hand a little bit, you actually want it to light up so you can then see, because you might be working in some dark, you know, dark equipment cupboard or something. So it'd be nice to actually get the light going in order to line it up. I think, yeah, I've not taken this apart yet, but it feels like there is some sort of switch or something there. But they could really do with having a switch, so yeah, the light would come on as soon as you start moving the handles. The other thing is this: if you're not careful, there is actually a little bit of scope to just nip your finger there a little bit on the bottom of the handle, which is not a major thing, you get used to it, but I think they could have designed that slightly better to avoid that little sort of finger trap there. But apart from that, it just, you know, it looks and feels quite nice. Like most hand tools, it's sort of right hand draw orientated, but in fact you could actually use this left-handed quite easily. You know, you sort of grip it, you can still quite easily use it that way or that way. So that's not too bad. Although the lights, yeah, the light's only on one side. There's an additional LED on the back that just gives you low battery indication, and it's got a few different flashing patterns. Like for example, if it jams, or if it's, for example, if you release it partway through. If you take your finger off, it will release immediately. It doesn't sort of complete the crimp cycle. Yeah, so if you actually start a cycle, you can actually stop it immediately, and it'll stay where it is. For example, if it jams, and you can then force it to release. If you just lift the handle out, it will release. And this just flashes to indicate that it hasn't done a complete crimp on that operation. I think we need to take a look inside this. Comes with a charger. It's a bit annoying there. You've got yet another charger to your arsenal of other chargers. It might be quite nice if this used like standard Makita batteries or whatever, but they've got their own battery for it. So just yet another charger. Fairly standard fare for a sort of power tool charger. One nice little detail, it's got the little eyelet thing so you can hang it on there, and it even tells you, there's even a little legend on the back here that tells you what the dimension is to put the screws in the wall. One thing that's always puzzled me about power tool chargers, pretty much every power tool charger I've ever seen is not universal voltage. It's almost always sort of 220, 240 or 110 for those. Now you might say, well, okay, you don't take power tools abroad very often, whatever, but certainly in the UK it's very common on a building site to only have 110 volts available for safety. They tend to use a centre grounded supply, so you've only got 55 volts above ground. So it's, you know, quite likely you might want to use a power tool charger on either 240 or 110, but for some reason I just don't understand why they don't make them universal input. It's not, you know, difficult to do these days. It just seems a little bit peculiar. But so this looks like a fairly just a fairly standard charger. I think it's about a 40-minute charge. So it just clicks in. The charger comes with a European type plug, but they supply this UK converter. You just screw it on and it becomes a UK plug. So it's all just sort of fairly conventional, but I think we'll take a look inside, and I would expect to see some quite nice engineering. Now, firstly, I noticed the motor is actually surprisingly small. Obviously there's a sort of significant amount of gearing down on there. I was a little bit surprised to see a motor that small. Just a little PCB on here with a LED on it. And I think it's also got the some switches. There is some sensing. I'm guessing it probably does load sensing via measuring motor current. But you can hear a couple of little clicks as it closes up. Comes apart quite nicely, just the two halves and the metal shell inside. So you've got the motor and then this control PCB at the bottom. So on this control board it's all pretty much as expected. We've got a little pick on there controlling everything. This side we've got 4 MOSFETs set up as an H-bridge, so you can drive the motor in each direction, sort of forward and reverse. And there's a big 0.04 ohm current sensing resistor here, so it can measure the motor force, and just a bunch of passives, nothing really very unexpected. In circuit programming pads there, just a few various passives. I'm guessing maybe an op amp here to boost up the signal from this current sensing resistor. Then we've got the battery tags just soldered down, and they're a little just sort of push fits into this PCB and then soldered down to the main board. So that's all pretty much. The only thing that is a little bit surprising on this is that it's actually a 4-layer PCB, which seems a little bit excessive, but it's not a cheap bit of kit, so it's probably not a huge additional cost. And this PCB on the side, all it is just got 4 little micro switches on it that sense the various mechanical goings on. I'm not going to take the mechanics apart. So you can see these hand levers pull this section back, that there's a sort of crank in there to push the jaws down, and then you can see this, just about see the worm gear in there that pulls this brass bit forward. It's not quite clear whether that operates the same bit or uses a separate mechanism to actually pull the jaws, but I'm not going to take this any further apart. But it's all sort of nice sort of steel, you know, as you'd expect, big lumps of steel. You know, about the only plastic part is the actual handle, and that feels like a very robust sort of glass-filled plastic material. It feels quite solid. We'll take a quick look at the battery, which incidentally has got one of these handy little gauges on it. Now, what's interesting, this little gas gauge board, it looks like all it's doing is it's looking at the battery voltage. It's not attempting to do any actual sort of gauging, because it's only got the 2 power connections to it. There's no connection, there's no internal battery management or even protection circuit in here as far as I can see. So this has got an Atmel 80 Tiny 13 and 7805 regulator on there. But, Samsung cells, standard 18650 size. So yeah, this isn't welded. This just unscrews. So it would be fairly easy to replace these cells as and when they after you've done your umpteen billionth crimp and the battery is finally peg out. But there's probably going to be a temperature sensor in there. I can't actually see it. It might be on that PCB. Right, take a quick look at the charger, which I'm sure we'll see some nice construction quality. It's got all the leads plugging onto the PCB there. Sort of cord grip detail using PCB. Decent sized fuse, mains input filter. Slightly unusual feature, I've never seen this before. I can only assume this is to improve sort of thermal conduction slightly. It's clearly not for electrical conductivity. These lines aren't actually in the path of the conductor. And this board has got conformal coating on it, which is nice to reduce the impact of any moisture. So I'm not really sure, I'm not really convinced how much difference those would make, but it's pretty much a zero cost thing, which I've never seen it done before. Slightly unusual architecture. We've got an HC 40106 here rather than a dedicated sort of switch mode controller, and there's actually a PIC here, PIC 16F616 PIC, which is actually doing all the control back through the opto isolator. But yeah, very nice build quality. A slightly unusual architecture. It may well be this. Yeah, this may well be a third-party thing they buy in or get made to order, from a specialist supplier. One interesting thing I did notice: there's a 0 ohm resistor down here, just connected to 2 pads that don't actually go anywhere. It's not connected to anything. I can only imagine that's something to do with maybe a test jig, so that there's maybe perhaps different build variants of this, and they use that resistor so the test tube can know which version is being tested. I can't really think of any other reason why you'd do that. I couldn't see any obvious dents from test probes on there, so I don't think it's actually been used. But I can't see why else you'd have just a solitary resistor sat there connected to nothing. So one very, very nice tool. It is quite expensive. Most people probably couldn't justify it. I probably can't really justify it, but it just seemed like such a nice toy to have. I haven't bought myself any nice toys for a while, so yeah, really, really nice. They do a few different dies. I think these do look like fairly standard tool dies. I don't know, how special they are, or whether they're peculiar to this particular unit, but they do a few variety of different ones. What I just noticed in the manual is there is a way to turn the lead off if you press the button while inserting the battery, so it disables the lead, but I don't actually know why you'd really want to do that. I'd much rather have it so the lead actually came on as soon as you touch the button. That's really, I think that's the only thing I can fault this on. It doesn't like the lead as soon as you press the button, but other than that, it's great fun.